Saxon Algebra 1, Lesson 116. This is a gem, you guys. This lesson is called the Quotient Rule for Square Roots. Oh, that sounds so hard, doesn't it? It's not. It's fun. Square roots are kind of confusing looking because they have those crazy pig houses, but we're getting used to them, right? It's not so bad. Okay, as a reminder, we know that if we have the square root of 6, for example, and we want to simplify that and break it down, we can see that as the square root of 3 times 2, right? 6 is equal to 3 times 2. And then we can rewrite that. This is where I think of the 3 little pigs. They can live together or they can move into their own houses. That's perfectly fine, right? Whatever makes us happy. And we can go in this direction too. If we had these two together, we could see it like that and then like that. So this is a train of thought that we're used to. And what we're going to see is that we're kind of at this stage. If we're dividing in a pig house, we can rewrite those pigs into their own homes as well, okay? So this is super cool. We're going to use it as part of our calculation process in this. Okay, John's instructions are to write this in simplified form, okay? So we look at that and go, well, it looks pretty good the way it is, but we can do better. So the first thing we're going to do, we see this fraction living in a pig house, and we go, oh, let's give each pig its own apartment. That's better. Immediately, I feel 100 times better. As a mathematician, this is like water on my eyes. However, this is a screaming fire alarm because we do not, as mathematicians, we do never, ever like to see pig houses, radical signs, in our denominators. That's just wrong. We don't want it. We don't like it. There's an easy fix, but as soon as you see that pig house in the denominator, I want a screeching air raid siren to go off in your brain. Is it happening? Just embrace the evilness of that. So here's what we do. We have a process that's called rationalizing the denominator. And it's super easy. We want to turn this into a number without a pig house. The easiest way to do that is to multiply it by itself, right? Because this is going to be, when we multiply this, this is going to become square root of 9, which is going to become 3, right? So by multiplying any number by itself in a pig house, the two pigs in the house will jump out as one pig out of the house. Excuse me, that's another way of looking at this. So now we have a cute, attractive, perfectly acceptable denominator. However, we also have to deal with the top, because if we multiply the bottom by the square root of 3, we have to multiply the top by square root of 3. But that's fine. And square root of 15, right? Because we already had the square root of 5. So we multiply across. It stays the same from here to here. This is our final answer. This is the simplified version of this original expression. Does this look less simple than that to your brain? In time, that will develop. In time, you'll look at this and go, ew, and you'll look at that and go, oh, that's so much better. But for right now, you might think, well, that looks weird too. So, roll with it. We're going to do a lot with these next year. Okay, here comes another one. It's a little bit kookier up top. Okay, we don't have to break the pigs into separate apartments, but we still have the same problem. And we've got a square root in our denominator. It's easy to fix. We know that all we have to do is multiply it by itself. And I will tell you right now, spoilers for next year, right now we just have a cute little pig in his pig house. Next year we're going to have more complicated expressions that we'll have to rationalize. But for now it's super easy. Oh, excuse me. We just multiply that little pig by his twin brother, and we know that together they'll jump out as a single 2. So Square root of 2 times square root of 2. In my brain, I see square root of 4. I know that's 2. So the little pig jumps out, right? 2 inside the house jump out as 1. That's another way of looking at it. I know I'm saying it over and over again, but that's because I can't see your faces and I don't know if you're distracted. Okay, but if we do that to the bottom, we have to do it to the top as well. And our top here is a binomial. So I'm going to put binomial brackets around it. And so now we have to distribute this across our binomial and across the frowny face that was up there. All right, I am just breathing freely now because that air raid silent isn't screaming anymore. But now we're going to have 4 times the square root of 2 plus this times this. Oh, this is just like this going this way, isn't it? So this will be square root of 6. That is our final answer. I'm going to make my bar a little bit bigger. Okay? So the denominator process was the same, but in the numerator, we distributed. And here comes the last example of this lesson. It is 2 plus the square root of 15 over square root of 5. Notice that I'm giving myself a lot of white space around my numbers. This is a lot going on, you guys, and these pig house signs make everything look cluttered. Give your problem room to breathe. You may or may not appreciate that extra space, but I will tell you that anyone who's looking at your work, and we all know that in the real world, people are going to look at your calculations. It's easier for other people to follow what you're doing if you give their eye a little bit more space to figure out what's going on. Okay, so we look at this. The air raid sirens go off. I don't like to see a radical sign in my denominator. No, that's a times. So I know 2 pigs in the house equals 1 out of the house. I'll multiply him by his buddy, and that's going to give me what I want on the bottom. Yay. Oh, it's like sunshine and a meadow when I see that radical sign gone. All right, but if I multiply the bottom by square root of 5, I have to do the top as well. This is a binomial, so I better do that, and I better do this, right? This needs to get bigger too. All right, so I multiply 2 times the square root of 5 is 2 square root of 5. These 2 guys can go on the inside . 15 times 5 is 75, right? Okay, now this looks really good, but here's the thing. We can simplify this, right? Let's do a quick factor tree. 75, I think of it as quarters. I think of it as 25 times 3. 3 is prime, but this breaks out into 5 times 5. There's a pair of 5s that can come out, and they'll sit right out here, right? And then all that'll be left inside is the 3. So here's my final answer. 2 times the square root of 5, that's that, plus, okay, here we go. The pair of 5s comes out, and all that's left inside is the square root of 3, and then the whole thing is over a plain happy 5. That's the right answer. That involves one more step, because this time we had to simplify within the radical. And I don't think we've done that in a while, but I guess you guys maybe have been doing it in the homework, but that may feel a little rusty in your brain. Just remember to make a prime factor tree and look for pairs of factors, because every 2 pigs in the house is 1 pig out of the house. Okay, that is lesson 116. I fit it all on one page. I feel really good about it. I hope you enjoyed it too. Okay, bye.